Hello everyone, today we will solve some numerical problems based on variational principle. Here the first problem is that we have to find the shortest distance between 2 points for a curve which is in a plane. Now here you can see that AB is a curve and A and B are its two endpoints. The coordinates of the A are x1, y1 and of B are x2, y2. So the path length for this whole curve AB can be written as I is equal to x1 to x2 ds. Here ds is small curved part of the curve AB. So we can write it as x1 to x2. ds can be written as root dx whole square plus dy whole square. You can see here that this is your ds and this is your dy, this is your dx. So this angle is your 90 degree. Then according to Pythagoras theorem, you can write ds whole square is equal to dx whole square plus dy whole square. So your ds will be equal to root dx whole square plus dy whole square. Let us say it is equation number 1. Now we can take here dx as common, so we can write the path length as I is equal to x1 to x2 root 1 plus dy upon dx whole square into dx. Here we can write dy upon dx as equal to y dot, so it will be x1 to x2 integration root 1 plus y dot square dx. Now we can assume it as a function, so f will be equal to root 1 plus y dot square. Now we will use the Euler Lagrangian condition. So that is del f over del y minus d over dx del f over del y dot equal to 0. So from here we will find del f over del y, that is equal to 0. Then we will find del f over del y dot. So it is equal to y dot upon root 1 plus y dot square. Now if we solve this value, then it comes out to be y dot upon root 1 plus y dot square equal to a constant. So here you can write y dot is equal to c upon root 1 minus c square. This whole term is a constant, so let us say it is equal to a, and your y dot is equal to dy upon dx. So when you write dy upon dx equal to a, then you integrate, then you can find your y is equal to ax plus b, where b is the other constant. Now you can see that this represent a straight line equation. So we can say that the shortest distance between 2 points on a curve will be a straight line. The next problem is the Brachistochrone problem. Here you can see that a particle of mass m is falling freely on a frictionless wire OA in a vertical plane. The velocity of the particle at point O is 0, and we will see that the path of the particle here will be a cycloid. Let us say at point P the velocity of the particle is v, and from distance P to P dash it travels with this velocity, and let us say P dash is equal to ds. So we can find here a time taken by the particle when it travels from P to P dash, that is equal to a ds distance with velocity v. So it will be equal to t can be written for this distance P to P dash is ds upon v. So for whole curve the total time will be written as t is equal to 0 to a ds upon v. Let us say it is equation number 1. Now let us suppose that when particle is at point P, it travels a vertical distance x. Because at point O, you know that the velocity of the particle was 0, so it will have the only potential energy. At point P, this potential energy will be converted into kinetic energy. So we can write the kinetic energy is equal to potential energy. So here you can find the velocity of the particle, and it will be equal to root 2gx. Let us say it is equation number 2. Now we will write the value of v in equation number 1, and it will be written as t is equal to 0 to a ds. You know that it is equal to root 1 plus y dot square, and v is equal to root 2gx. So here your function will be of the form f is equal to root 1 plus y dot square upon 2gx. Now you may note here that yesterday when we have written our function of the form fy y dot x, here you can see that for the curve type problem our function will have the y dot and x. Now because your function is like this, so here you can use the Euler Lagrangian condition, that is del f over del y minus d over dx, del f over del y dot equal to 0. Let us say it is equation number 5. Now here we will find del f over del y, and that is equal to 0. Then del f over del y dot, it is equal to y dot upon root 2 gx root 1 plus y dot square. Now this value we will put in equation number 5. So when we solve it, then you find that y dot upon root x root 1 plus y dot square is equal to a constant, that is equal to c. Let us say it is equation number 6. Now here when we solve this equation, we can write as y dot square is equal to x upon b minus x, where b is equal to 1 upon c square. B is here the other constant. So here we can find dy upon dx, that will be equal to root x upon b minus x. Now we will write it as y is equal to integration root x upon b minus x dx plus c dash. Here c dash is the other constant. Let us say it is equation number 7. Now we can solve this integration by taking x as b sine square theta. So dx will be 2b sine theta cos theta d theta. So we will put the value of dx here, and x is b sine square theta. So when you put these values, your integration for y comes out to be of the form b integration 1 minus cos 2 theta in bracket d theta plus c dash. So when you solve this integration, your y comes out to be b theta minus sine 2 theta upon 2 plus c dash. Because your particle at initially was point O and it passes through the origin, so your constant here will be 0. So here your y will be equal to b by 2 theta minus sine 2 theta, and your x is equal to b sine square theta. You can write it as in terms of the cos theta also, and it will be written as b by 2 1 minus cos 2 theta. So your x is b by 2 1 minus cos 2 theta, and y is equal to b by 2 in bracket 2 theta minus sine 2 theta. So these two equations represent the equation of a cycloid. So when a particle falls freely in a vertical plane on a frictionless wire, then its path will be a cycloid. Thank you.